Module 7. Using AlgoBuilder with the SensorTile.box PRO. In this module, we will use the AlgoBuilder tool to build a project targeting the SensorTile.box PRO and use Uni Cleo to see real-time output. Now that we've seen some examples of how to use the SensorTile.box PRO in various ways, let's turn our attention to some of the other tools that ST provides, which you can make use of for accelerating your development. AlgoBuilder is one such tool. AlgoBuilder is a graphical tool used to design your own algorithms using simple functional blocks, which you can drag and drop, connect, and customize. There is a wide range of functional blocks available for use in your design, including FFT, sensor fusion, magnetometer calibration, gravity vector, rotation vector, pedometer, and many others. Let's spend the next few minutes exploring how we can use AlgoBuilder together with the SensorTile.box PRO. Open AlgoBuilder. AlgoBuilder uses several other standard ST tools as part of its normal operation. After installing AlgoBuilder, we need to configure it so that it can operate with these required tools. STM32Cube IDE is used to compile firmware source code, and Uni Cleo is used to interact with the sensor tile and display results. In AlgoBuilder, click on File and then go to Application Settings. In the first box for the Uni Cleo GUI path, click the Browse button. If you have installed Uni Cleo in the default location, the Browse window that appears should take you there immediately. Highlight the Uni Cleo-GUI.exe file and click Open. Now do the same for STM32Cube IDE. Click the Browse button for STM32Cube IDE, and as long as you've installed to the default location, you should be taken there. Highlight the STM32Cube IDE.exe file and click Open. Next, click the Browse button for STM32Cube Programmer. Again, if you've installed this tool to the default location, it should appear in the Browse window. Highlight STM32_Programmer_CLI and click Open. Now click OK to save your settings and close this window. AlgoBuilder automatically started a new project for us when it launched. Let's save this project to a new folder before we start modifying it. Click on the Save Design icon in the toolbar. Navigate to /STBox Pro-Workshop. Click the New Folder button at the top of the window. Give the new folder the name AlgoBuilder. Now double-click the new AlgoBuilder folder to open it. Then click the Save button. We're ready to make our first design. We need to specify a firmware location and the target hardware for this design. Click on the Firmware Settings icon in the toolbar. Next to the Firmware Location text box, click on Browse. Navigate to /STBox Pro-Workshop AlgoBuilder. Click the New Folder button at the top. Give the new folder the name Firmware. Double-click the Firmware folder to open it. Click the Select Folder button at the bottom. Now we are back to the Settings window. Under the Toolchain drop-down, make sure that STM32Cube IDE is selected. In the Target drop-down, choose SensorTile.box PRO. Click OK to save your settings and close this window. On the left side of the screen, we can see a panel labeled Library. Here is where you can find all of the available function blocks, organized by category. A full description of each of these is beyond the scope of this workshop, but in brief, there are blocks for logical comparisons, various mathematical operators, blocks to extract raw sensor data, and many of ST's motion libraries. As a quick example, Let's see how easy it is to build a demo using only AlgoBuilder, and without writing any code, use the MLC model that we trained in the previous module. We see in the main window here that the project starts out composed of a single functional block labeled Sensor Hub. This is the starting point for all projects and represents the main program loop, which is responsible for gathering sensor data from onboard sensors. Click on the Sensor Hub block. We can see on the right a description of the function block, including output types and properties. Below this, there is a control panel for setting the block's properties. In this case, this includes the sensor's data rate and full scale. Since we will be using the MLC model we have previously created, let's change these settings to match those we used when we trained the model. In the data rate control drop-down list, choose accelerometer. This setting will cause the Sensor Hub block to read new data on each data ready interrupt from the accelerometer. Now in the data rate text box, enter 30 to match the sampling rate we used when training the model. Finally, for accelerometer full scale, choose 2G. These settings match the sampling rate and full scale we used when training the machine learning core model in the previous module. We won't use the gyroscope in this example, so you can leave its full scale at the default value of 500. In the library panel on the left, scroll down to the Sensor Hub category and expand it. Drag the acceleration block over to the design space and drop it at the upper right of the Sensor Hub block. Click on the acceleration block to select it. Again, you see a description on the right, including the block's input and output data types. In this case, we see the block takes input directly from the Sensor Hub block and provides as output an array of 3 floating point values, one for each axis of measurement. Connect the Sensor Hub block to the acceleration block by drawing a line between the output node of the Sensor Hub and the input node of the acceleration block. Let's add one more block to our design. In the library panel, scroll up to find the display category and expand it. Drag the graph block over to your design space and drop it next to the acceleration block. Click on this graph block to see its properties. This block can display any kind of scalar data in the form of an XY plot. In the Properties window at the bottom right, click the drop-down list for data type. Here we see Custom, as well as 3 types of built-in standard configurations. Choose Accelerometer to configure the graph for standard 3-axis accelerometer data. Draw a new line to connect the output of the acceleration block to the input of the graph block. We now have a completed project. The Sensor Hub block samples all sensor data at each interval. The acceleration block extracts the accelerometer data from the overall dataset, and the graph block sends the accelerometer data via the USB connection to our PC, where we can inspect it. Let's generate and build our project. First, click the Save Design icon in the toolbar. Click the Generate C Code button in the toolbar. Wait a few moments for the C code generation to finish. You should see a message in the console window that code generation finished successfully. Now let's build the generated code. Click the Build Firmware button in the toolbar. This may take a couple of minutes, so please feel free to pause this video until it is complete. When completed, you should see a message in the console that the build process finished with 0 errors and 0 warnings. The next step is to program the firmware to our SensorTile.box PRO. Make sure your board is connected to your PC with a USB cable. Click the Program Target button in the toolbar. We will need to enter DFU mode to program the board, as we did previously for Pro mode. To enter DFU mode, first turn the board off at the power switch. Hold down button number 2, which is the button closest to the power switch. With the button held down, turn the sensor tile back on. AlgoBuilder will automatically detect the board, and after a few seconds you should see a message in the console that the firmware binary file was programmed successfully. Let's launch Uni Cleo to see the results. Click the Run Uni Cleo GUI application icon in the toolbar. Uni Cleo should launch and automatically detect your board. By default, the firmware will expose the SD card to Windows as a removable storage device. We need to disable that so that we can instead stream sensor data over the USB connection. Click the SD card button to unmount it. The icon on the button will change from green to red once the SD card has been unmounted. Now click the Start button in the toolbar to start streaming sensor data to your PC. Click the acceleration icon on the left side of the window. This will open a new window showing a plot of the real-time acceleration data from the LSM6 DSV16X accelerometer. Move the board around and see how the plot changes. All of this was done with only 3 function blocks in AlgoBuilder and required us to write no code. Let's now add our MLC model to the design. Close the acceleration graph and then click Exit in the main Uni Cleo window to close out of it. Return to AlgoBuilder. In the Library panel on the left side of the AlgoBuilder window, scroll down to the Sensor Hub category and expand it if necessary. Click on the FSMMLC block and drag it over to your design. Drop it into your design below the acceleration block. This block has 1 input and 2 outputs. Draw a new line from the Sensor Hub block output to the input of the new FSMMLC block. Note you'll now have 2 lines drawn from the output node of the Sensor Fusion block. Click the FSMMLC block. In the Properties window at the bottom right, find the setting labeled Number of FSM, short for Finite State Machine. We are not using the FSM feature of the LSM6 ESV16X for this demo, so change the default value of 1 to 0. The setting for number of MLC should remain at the default value of 1. Click the Load UCF file button. Here is where we'll load the UCF file that we created previously, which contains the configuration for the machine learning core on the LSM6 DSV16X sensor. Navigate to C:\\STBox Pro-Workshop and select the training.ucf file, then click Open. Now we need to send the value being output by the MLC block to our PC. In the Library window on the left, scroll up to the Display section and expand it if needed. Drag the value block into your workspace and drop it to the right of the MLC block. Click on the value block and look at its Properties window. Ensure the data type is set to Custom. Then set the number of values to 1. For window name, enter MLC. And for value 1 name, enter MLC out. These 2 settings are labels that will be used by Uni Cleo and will not affect the actual data output. Finally, connect the bottom output node of the FSM MLC block to your new value block. You'll leave the top output node disconnected since we are not using FSM in this example. Now the design is done. Click on the Save Design icon. Click the Build Firmware icon. This should be a quick process since only a few source code files will have changed. When the build is finished, you should see a message that the build process finished with 0 warnings and 0 errors. Program the firmware to the board once more by clicking the Program Target icon in the toolbar. Reboot the sensor tile in DFU mode by turning off the board using the power switch, then turning the board back on while holding button number 2. After a few moments, you will see a message that the firmware binary was programmed successfully. Finally, click the Run Uni Cleo GUI application icon in the toolbar. Uni Cleo will launch and detect your board. Click the SD card button at the top to unmount the virtual storage and enable data streaming. Then click the Start button to start streaming data. We will now have a new icon at the left labeled MLC. This is the output of the LSM6DSV16X machine learning core, which is running your custom MLC model. Click the MLC icon to open a new window which will show this output value. Also click the acceleration icon to show the real-time accelerometer graphs simultaneously. You should now be able to see the MLC engine detect the stationary movement and shake conditions that we trained earlier. Remember that an MLC output of 0 corresponds to stationary, 4 is movement, and 8 is shake. Feel free to pause this video and experiment with this if you would like. As you have seen, AlgoBuilder allows you to quickly prototype and build firmware images without needing to write any code. Let's return to AlgoBuilder one more time. We have created a simple demo that outputs real-time acceleration data and MLC output. AlgoBuilder is capable of creating designs of much higher complexity. For example, click on File and then Open Design. A number of sample designs are provided that demonstrate various features of AlgoBuilder. Open example 1_demo. Close the 2 prompts that appear. We are not actually going to build these now. This example is a design that performs sensor fusion and free fall detection, while simultaneously outputting a variety of data to the GUI. Now that you know the basics of how to use AlgoBuilder, we encourage you to examine this and the other provided example projects to see the kinds of functionality available to you with this tool. For now, please close Uni Cleo and AlgoBuilder to prepare for the next module. In this module, we saw how to use AlgoBuilder to build a project that targets the SensorTile.box PRO and used Uni Cleo to examine the output. This concludes Module 7.